Today on How It's Made. Robotic hunting decoys. As you can see, they're all stuffed with technology. Canned tomatoes, all you ever wanted to know, but were afraid to ask. Scoreboards, essential for all sports fans around the globe. They're real game changers. And lassos, who promise not to tie you up with all the details. But first, the latest taxidermy trend is movement. Today, many museums and nature attractions feature wildlife models that move. These robotic replicas look so lifelike that hunters use them as decoys, and game wardens use them as traps to catch poachers in the act. Activated by remote control, the robotic decoy's head turns and its tail wags. More elaborate models have additional moving body parts. The decoy can be set up directly on the ground or installed on a track system, which moves it along as though it's walking. At the factory, they begin by waxing a two-part fiberglass body mold. This one is for a deer. Waxing the mold cavity eases the extraction. Steel reinforcement bars are put in the legs. The steel sticks out of the bottom of the hooves to anchor the decoy to the ground. They apply the other half of the mold and clamp all around the perimeter, holding the two parts together. The deer's head is prepared in the same way, and a small amount of the casting material is poured in. Roughly 3 litres goes in to fill the body mold. Then the head mold is clamped on. The casting material is expanding polyurethane foam. It begins swelling immediately, and within 2 minutes it reaches full expansion, going from a liquid to a flexible solid. Over the next hour and a half, the foam cures to a hard, inflexible state, at which point they remove the clamps and extract the casting. Some foam has leaked from between the two halves of the molds and between where the head meets the body. Sanding ensures a perfect finish. Sockets for the eyes are then bored into the foam deer. The nostrils are drilled out with a mini router. The glass eyes are secured in place with wet clay. When the clay dries, the eye is set firmly in place. No faux fur for these decoys. Workers scrape any remnants of flesh off a real deer hide, then wash the hide and apply a preservative. The hide is pulled over the foam deer. The fur is snugly fitted with a combination of staples, glue and stitching. Once the deer is fully dressed, it's put aside for 4 to 6 weeks. This gives the preservative time to penetrate to dry and harden the hide. This is essential to protect against insects and prevent the hide from decomposing. The taxidermy phase of production is now complete. Now the head is removed so the robotics can be installed. These are the parts which will make the head move. The first step is to drill out a cavity inside the neck. This creates a pocket in which to install the plastic housing which contains the robotic components. First, it's a compact motor which drives this hard plastic gear. Next in is the receiver for the remote control. Then a AA battery pack that powers both the motor and the receiver. All this goes into the neck pocket. Now they drill out a cavity in the neck of the head mold and insert a gear and shaft. The final step is to mount the head onto the body, inserting the shaft into the gear on top of the motor. So now when the motor runs, it rotates the gear, which turns the shaft, moving the decoy's head. Each moving body part has the identical mechanics, its receiver corresponding to a dedicated switch on the remote control. The remote can work from up to half a kilometre away and can be programmed to put the decoy through a preset motion routine. So there you have it, robotic hunting decoys, the bare necessities. Often considered to be a vegetable, the tomato is actually a fruit. It's grown from the ovary of the plant and it has seeds. It's also the most popular one on the planet. Automation of the canning process in the last century has made that possible, ensuring that tomatoes preserve their #1 slot. There are over 2,000 varieties. For canning purposes, they grow a type with a thick skin and firm consistency, so machinery can pick and sort them without damaging the flesh. Rotating clippers cut the vine as the harvester drives over the crop. Once cut, the plants travel on an elevator belt up into the harvester. Inside the harvester, metal prongs shake the tomatoes to free them from the vines. An electronic colour sorter rejects the green ones. A conveyor transfers the red, ripe tomatoes to a trailer travelling alongside the harvester. Once they have a load of 22 tonnes, they deliver the tomatoes to the canning factory. Here they fill the trailer with water to float the tomatoes out through a door at the side. The water, dirty from residual soil, drains away through the slats in the belt. The tomatoes land in a clean, water-filled channel, and here any rocks sink to the bottom and are removed. The tomatoes float into a big tank, where jets churn up the water for a more gentle cleansing action. The tomatoes then head up to a sorting line and travel over metal bars. Smaller tomatoes fall through the gaps. They'll be used to make tomato juice. The others fly on past 60 tiny cameras that detect pale or yellowish tomatoes. Pneumatic fingers knock those tomatoes out of the batch. It all happens in less than a second. Now it's the human eye that inspects the tomatoes. They send any rejects to another part of the factory to make juice. The rest take the plunge into a very hot bath. This scalds the tomatoes and loosens the skins. The tomatoes then travel on a moving bed of rubber discs, and this gently pulls the skins away from the tomatoes. A spray of water washes away the skins, which then fall through the rubber discs. This ensures no mess is left after peeling. The now peeled tomatoes travel onto another conveyor, where sprayers give them another rinse. This conveyor controls the flow of peeled tomatoes into the processing room by metering the produce as it moves forward. Ahead, the dice awaits. It has 3 sets of cross-cutting blades to make light work of the tomatoes. The tomatoes tumble down a chute into the dicer and are chopped into small cubes. The diced tomatoes pass workers who pick out pieces that aren't perfectly red. They also remove any pieces of core. Leaving the cleaning station, the cans queue up for a fill-up. Ahead, the diced tomatoes flow into metal pockets. This portions them out, ready for the cans. The pockets rotate forward to meet the cans, now moving in sync below, and the bottoms of the pockets open to release the contents into the cans. They add hot tomato juice and flavourings. Lids advance towards the open cans. They land on top, and a machine crimps the lids to the cans, creating a double seam for a complete seal. Now in airtight cans, the tomatoes head into a hot oven for a quick cooking, which sterilises them, removing the need to use preservatives. The cans now get their labels. They spin across wheels that apply glue to the sides, and then roll over paper labels which adhere to the glue-covered cans. Here's the labelling action slowed down. The label contains brand and nutritional information, as well as the exact time of production. This means it can be traced if there's ever a quality issue. It's taken about 1 hour for these tomatoes to be harvested and canned. All that's needed is a tin opener and a recipe. Coming up, we're going to learn how lassos are made. Just to warn you, it's a bit ropey, but we're sure you'll enjoy it. And the writing's on the wall. Well, on scoreboards, actually. We visit a factory where the numbers have to add up. Join us after the break. There you go. It's half time. In every sport, fans need to know the score. In the early days, scorekeepers climbed ladders to scroll numbers on a slate. By the time they were done, the score might have changed, and it was time to start again. Thank goodness modern scoreboards serve up the numbers in an instant. Today's digital scoreboards light up within seconds of a game change, delivering results fast for the fans, cheering in the stands. Production starts with the front of the board. A computer program guides a plasma torch, which cuts precisely sized slots in a sheet of high-grade steel. The slots will house the illuminated characters. Narrower strips of steel are fed into a press that bends back the edges to create tabs. It's these strips that will serve as the sides of the scoreboard. Using a special compressed air tool, a worker clinches the tabs to the back of the scoreboard. This tool punches and stretches the steel to interlock it, joining the parts without using screws, rivets, or welds. He then attaches the plasma cut front panel to complete the basic structure of the scoreboard. A powder paint coating is then sprayed onto the entire scoreboard. Then it's into a giant convection oven for 14 minutes to cure the powder paint. The result is a tough powder paint skin that will offer all-weather protection. They're now ready for the working parts, including LED light-studded digit boards, a data transmitter, and a receiver. The receiver is connected to the power source and installed inside the cabinet. The worker pulls the antenna through a hole so it protrudes from the front, and he bends it out of the way for now. There are several light-studded digit plates on a scoreboard, and each can flash any number. He wires them in a loop, interconnecting them in what's known as a daisy chain configuration, and plugs in a ribbon-style cable to link the digits to the scoreboard's processing module. He inserts the digits in the slots on the front and shields them with a sheet of transparent polycarbonate. He screws a metal framework around each assembly to secure them, then confirms that the wiring is good and that all the numbers light up. He connects the wireless module to the numbers and connects it to a power source. He mounts the module to a panel, which will then be installed through the back of the scoreboard cabinet. The company logo is printed on adhesive back paper, followed by some fierce-looking team icons. A weatherproof coating will be applied to the paper graphics at a later stage. They also use vinyl decals, and here the worker peels away the unwanted material from around the lettering in a process called weeding. After transferring the decal to applicator tape called pre-mask, she carefully positions the grouping on the front of the scoreboard. Satisfied that it's in the perfect spot, she tapes it at the top, and then peels off the backing, and the letters cling to the pre-mask. All it takes then is a squeegee to smooth out any bubbles or buckles. She then removes the tape. Then lifts the pre-mask very carefully so as not to lift any of the decals in the process. With all the lettering now in place, the characters on the board make sense of all the LED numbers. The scoreboard is equipped with a speaker and horn, which will go off in the event of a score. And no need to run a cable from the scoreboard to the keyboard. It's all done by remote control. Using that system, a technician now tests all the functions of the scoreboard. That takes about 20 minutes. And when it's done, he confirms the scoreboard is ready for action. Today you can get scoreboards in any shape and design. But when it comes to letting the fans know what's happening in the game, it's very good at getting its point across. If you understand American football, that is. A lasso is a classic cowboy tool designed for catching running cattle. On one end, there's a moving noose you throw over the animal's head. This loop then tightens around the neck or horns, safely stopping the animal in its tracks. Or that's the theory. Ride 'em, cowboy. Working a lasso requires tremendous skill, so much so that some rodeos typically hold roping contests and feature performances of astonishing maneuvers. The rope maker starts by looping 5 nylon threads around a bushing mounted on a travelling box. He ties the end onto the first of 3 spinning eyes, then runs the 5 threads around the bushing and the second spinning eye, then back to the bushing. He then hops on his cart and drives the travelling box to another travelling box, pulling the threads for this lasso to a length of 14 metres. He transfers the threads from the bushing to a spinning eye on this second travelling box, then pulls the threads back to make the other half of the rope. When he arrives at the starting point, he loops the threads through a third spinning eye. Then he pulls all the threads to equal tension, cuts them from their spools and ties them off. The twisting process is next. A motor turns 3 spinning eyes, twisting the 10 threads on each one into a strand, and the 3 strands together into a lasso rope. The twisting force pulls the 2 boxes towards each other. The rope maker puts a certain amount of weight in each box, and that determines the stiffness of the rope. A rope this length takes about 5 minutes to twist. The end is wrapped with electrical tape so that the rope won't unravel when it's cut loose. Here he pulls the rope at the centre to release some tension. Then just beyond the taped end, he snips the strands free. He knots them, then trims the ends with a hot blade that slices the nylon threads by melting them. He lays the rope in piping hot wax, and this treatment permeates the threads deep inside, setting the twist. After suspending the rope for a while to let the excess wax drip off, he connects it to a pulling mechanism inside a heated room, or weather permitting, outdoors under the hot sun. Stretching for a couple of days pulls out any waves, ensuring the rope lies perfectly straight. He then cuts off the knot and unravels just enough rope to tie a knot for what's called a hondo. That's the eye in the rope which helps build the loop. On the other end, he ties a different type of knot, one which will keep the rope from unraveling. Using pliers and a vise, he pulls both knots tight. Then slices off the excess with the hot blade and burns the ends to seal them. Now he ties the hondo. The hondo slides along the rope, loosening and tightening the loop. He hangs the hondo on a hook and, using a specially designed wheel, pulls it tight. Then he sews a piece of raw hide, called the burner, into the eye of the hondu. It prevents the eye from burning through as the rope slides through it. And banging it with a hammer seats it in the rope grooves. Finally, he stamps the company name on it and marks the rope's stiffness. Lassos come in various degrees of stiffness for different types of animals and purposes, such as roping cattle by the head or by the heels. So long, partner.